Ciao! So, just briefly, as you can see, I only wear one t-shirt, same one every time. I am Paul Hudson. I'm here to talk to you about instruments and why you should all be instrumenting your code. I'll talk to you a little bit beforehand about who I am. I code for basically every platform I can get my hands on, whether that's iOS or macOS or watchOS or Android or Xbox or even, let's face it, Windows Mobile. I do some code for that too, have done. I'm an equal opportunity love giver. My app's been used by the likes of Fender, UBS, and some tech companies. And I write lots of books, lots and lots of books. You may know Hacking with Swift. I also do Hacking with macOS, Hacking with watchOS, Hacking with tvOS, Hacking with server-side Swift, Pro Swift, Practical iOS 11, Swift Coding Challenges, and the next one out next week. It's going to be great. Dive into SpriteKit. I run a thing called the Swift Community Awards, and I even do online workshops. If you want to get in touch, please do. I am at 2straws on Twitter. Also on GitHub, also on Reddit, and also on Stack Overflow. Pretty easy to find once you have the 2straws bit figured out. Or email me, I am Paul at hackingwithswift.com. For the next 1 hour, if you go to this URL, you get a free book. It comes with 6 hours of video. It's my Pro Swift book. The Wi-Fi here sucks. So write it down, take a picture. It only works for the next hour. Everyone gets a free book. 5, 4, 3, 2, 1, hurry up. Next. Too slow. You instrument your phone, quite frankly. Anyway, instrumenting. It's the process of measuring your programs, analyzing its function calls, memory use, and more. And in today's thing, we're going to be talking about why you should instrument your code, what you should be instrumenting, when to instrument, and how to instrument. And realistically, that last one is the biggest and most important part of this talk. So I'm going to whiz through the first three and get on to the meat. First things first, why instrument? One of the things I hear people say is, iOS is so fast, why bother? And it is totally true that there are some amazing devices out there nowadays, the new iPhone 8, iPhone 10, they are crazy powerful devices, and every year they show a chart of the lines getting higher, they're twice as fast, 3 times as fast, they're really fast, so why bother? But you may know that in the Settings app, there's a screen which shows you the battery usage for all your apps. And as you can see here, for me, Tweetbot is taking up 38% of my battery on my phone. And no one wants the app to be there, because that spot there is the cone of shame. So check your phones. Is your app in the top 3 or 4? You may also hear, Swift hasn't got all that memory management pain of Objective-C. I beg to differ. It really does. There are so many pitfalls that can hit us as Swift developers. We have syntactic sugar like capture lists, unknown self, or the weak keyword. To try and work around them. But there are still all sorts of implicit retains in the frameworks we use. And of course, reference types are a massive pitfall. You all know class reference types, so are closures. Closures are reference types. They can really screw with your memory. So if you are not currently instrumenting your code, you're going to hit problems. So, what should you instrument? That's the why. What? I'll make it as simple as possible. Which method should be instrumented? And the answer is only the ones you don't want to leak. Hopefully, is all of them. Because memory can go in all sorts of ways. There's things like abandoned memory. When you allocate it for your own use, and you kind of use it for a while, then you forget about it. It's the unloved child. Then there's lost memory, an actual leak. You allocated it, you ditched the variable, the property that's pointing at it, but Arc could not release it for some reason. So it's literally holding around where you cannot get to. And then there are caches. Memory you've allocated because you want to make your program faster, whether that's your own cache or something built in like the UI image named cache. And of course, profiling is way more than just simple leaks. There's also CPU usage. There's memory usage. There's draw speed. And there's I/O, writes and reads. Now in this talk, I'm not going to be covering I/O. That's a whole other section of instruments we can look at another day perhaps. Pragma 18. But I'll have a look at the other 3. When to instrument your code? Again, another simple rule for you. I do not want to see your pull request before you instrument. And this should not come as a surprise. This is kind of the classic software development approach. Step 1, make it work. Step 2, make it right. Step 3, make it fast, right? And this was Brian Kernighan 30 years ago. This is not news. And if Brian were to write this today, I really think step 4 would be, now you can open a pull request. Now it's cool, let's see your code, right? That's how we work, in theory. But in practice, these phones are so crazy fast, people forget the make it fast step. And let's face it, lots of developers forget other steps too, right? It works, it's going into GitHub, you know. Because sadly, doing mediocre work takes a lot less time than doing great work. And most people will not notice the difference until it's too late, when those crash reports come in from iTunes users. So you profile early, and you profile often. And that applies to you if you are sitting out there thinking, you know, I'm a senior developer, I'm great, I don't need to do profiling. No one gets it right the first time. No one. We all have to profile our code. Okay, that's the easy stuff gone through. Why instrument? What to instrument? When to instrument? Let's get on to the real stuff, the bit you're all here for, I'm sure. How do you instrument? And this is the bit that makes folks' eyes glaze over, or their brains melt through their ears. I've tried to make it as simple as I can. I've made a trivial sample app. And this app downloads news stories from the internet. Now, I've put a star there because everyone knows that doing a live demo with the internet never works. So I've baked them into the app. You get the idea. Then it uses a bit of rendering to get the title of news stories onto the images. It shows them inside a collection view, so you can scroll through it and select one. When you select one, you can read the story. And, because obviously I like the Star Wars opening crawl, the story content just scrolls gently, so you can just sit back and admire the great stories. Here is how my toy app looks. Collection view full of pictures, bit of fancy rendering on top of the pictures. When you find a story you like, tap on it, up it comes, and it just gently reads. So you can sit back and enjoy the news about whatever that story was. Let's see what Instruments thinks about that. I'm going to start off with Instruments 101, as it were. Easy stuff. And that is the core animation instrument. It profiles your display performance. And here it is working with the app. There's the instrument there, and there's my iPad in the bottom right corner. And you press record, and you start using the app. And you can see numbers whizzing by there. That's it reading the frame rate as you go. Now, I'm going a bit crazy with it because you have to move around to simulate. And here, those are my numbers. Now, the zeros, like I said, you have to move around, otherwise core animation does no drawing, so it says there's no frame, so it's 0. But otherwise, you can see, 45, 12, 56, 62, 72. It's okay. It's very variable. It's not great. It's not smooth. And this is actually an iPad Pro, which means it's supposed to be Pro Motion, which is really hard to Google for. But 120 hertz display. 56 frames a second, 72 frames a second, that's nowhere near what it ought to be. Now, in practice, this is actually a variable frame rate. It goes up to 120 hertz, but for battery reasons and so forth, it might be lower than that, but it should be as close as we can to get to this. And instruments can help us find out why. This is the core animation instrument again. Look in the bottom corner here, and you'll see this option, debug options, full of checkboxes you can check. I'll check the very first one, color blended layers, and watch what it does. It makes the UI green or red. And it's telling you the green stuff is fast to draw, and the red stuff is slower to draw. Because the green stuff has no alpha transparency. It's opaque. So it's a simple blit operation. Copy, 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 copy the pixels. When it's red, it means there's some amount of alpha in there, something that has to be multiplied by the current color to get the new color. So I actually have to do some more advanced drawing. And this is slow. And this is happening because in the code, I have this line. It's an iOS 10 API UI graphics image renderer. And it creates an image at a size. But by default, it makes it transparent. So even though all my images have 0 transparency, there's no pixels that have even slightest transparency, the image itself still has an alpha channel, so it's considered to be not opaque. and must draw using the slow route. So we can fix that. You just add a configuration and say you're opaque, and pass that when you initialize the image renderer. And straight away you get green. Green is good, red is bad. Next up, back to debug options again. You'll see all green. Loving it, it worked well. But there's another option down here, color misaligned images. And when this one gets checked, it will show you in yellow any images that are rendered at the wrong size. It's kind of murky brown on the screen, but it's yellow in instruments. They're rendered at the wrong size. Now, I'm not trying to insult you here, but obviously images are made of pixels, we know this. And the natural size of an image is its natural number of pixels and the width and the height, right? That is the size of the image. And drawing an image at its natural size is extremely efficient. Take pixel, put it on pixel. Take pixel, put it on pixel, and so forth, again and again and again. But if you draw your image even slightly wrong, a little bit, even 1 pixel off, now iOS has to stretch the pixels and interpolate the pixels, make them looking good on the screen, which is much slower. This happens because in the code, some poor junior code person, has written width 300, height 170 when drawing the images. They've hard-coded numbers, which is never a good idea. That may have been right before, it's not right now, so it's stretched. A better idea in this particular case is to read the layout dynamically and render it using those sizes. That way, if it does change again in the future, it will always be correct. And with that change, back to instruments again, press the button, check the box, nothing happens. Fantastic, worked perfectly. So, that is color misaligned images. Next up, I want to show you the next option, off-screen rendered yellow. What that means is, instruments will tell you anything that had to be drawn off-screen, separately, in its own drawing pass, before being drawn again to the main screen. And here, as you can see, that's everything. This is happening because the collection views have got a shadow. So, you have a collection view cell or an image or any kind of view. You want to put a shadow around it. To make that happen, iOS must take that thing off the screen and draw it to a temporary buffer. And it can then measure around what it drew. Because it looks for the exact shape. So if you have an irregular shaped view, you have an irregular shaped shadow. It can then, from that, calculate the shadow, draw that, get the finished product, and put that onto the screen. It's very clever. But when you have a collection view of stuff, each of which are drawing shadows, you're just going to burn through CPU time and GPU time and battery. It's not efficient at all. There is a simple fix, again. You can get your collection view cell, and you can say, I already know the shape of my thing. It's a rectangle. And you can give iOS the exact size of your thing you want to draw a shadow around, and it will use that to draw the shadow, hand it back to you in one drawing pass, significantly faster. Here's the current shadow code, and that's the better shadow code. You just tell it, here's my size of the rectangle, width is this, height is this, make it a Bezier path, use that for your shadow path. And it now eliminates a rendering pass. So these are the drawing speed bumps. You're avoiding blending. You're drawing at natural size. You're skipping second draw pass. But despite this work so far, all of those changes combined add up to only about 10 frames a second. We've gone from between 56 to 77 to 65 to 80. So it's better, but nah. Let's level up. We're going to switch to the Allocations instrument, which tracks how much memory you allocate from free and when. So here we are in the Allocations instrument. Again, it looks very similar. iPad in the corner, instruments in the top there. You just press record. It'll start reading your RAM. There's the program running. I'll swipe through it. I'm trying to use it. I'll open some stories to read. Just use it like a real user would do, basically. That, so a few stories. And then I can press stop and look at the results. Now, by default, it's showing you everything here, but you can filter it by typing things into this box. And in this case, I care about my collection view cells, so I'm going to type in collection view and ask more information about my cells in here. So you can go ahead and filter it, show me the collection view cells. And now it'll show you only those. And if you look, it's telling you there are 24 persistent UI collection view cells and no transient UI collection view cells. A persistent thing has been created and stays. A transient thing was created and destroyed. So there's 24, which really is not a surprise. Look at our collection view layout. You'll see 24 is the exact number of cells plus 4 for buffering for the next thing coming in. However, again, this is an iPad Pro. It's ProMotion. It's 120 Hertz. That gives you 0.0083 seconds to render the frame and do all the work required to render that frame. It's extremely hard to keep up with. The solution here is called UI Collection View Prefetch, which loads more cells than is needed and is very, very clever. It actually adapts based on user scrolling. So if they scroll down, it loads cells from below. They scroll up, it ditches those and goes back and loads the ones at the top again. And it is actually enabled by default for most people, but so many folks disable it. For example, IG ListKit, Instagram's extremely popular collection view replacement, disables it for you automatically. So if you haven't got it on, give it a try. Test it out for yourself. They think it hurts their performance. It may have hurt their performance, but don't let it hurt your performance. Give it a try. In code, it is just one line of code. Alternatively, you can just check the box in an IB, prefetching enabled. You can actually do your own customized prefetching if you want to, but honestly, this is good enough for most people. And now what you'll see in instruments, persistent 44. It's loaded more than is visible, and now you get silky, fast scrolling. It actually runs at 110 FPS at this point. So I've made 3 small code changes, 1 IB change, and it's significantly faster. Now, prefetching is obviously an example of a cache. That's what it's doing. It's caching rows that you don't see yet. But the allocations instrument is also great for tracking lost memory that's gone away. And I can show it to you here again. So, as before, iPad in the corner, press record, scroll around like a madman for a few minutes, testing out the app. Then read some stories, give it a going over, basically, to make sure it's really been tested out thoroughly. And this time, in the filter box, we're going to look for the word detail, because my detail view controller is called detail view controller, because I'm lazy. And what you'll see now is persistent 4, transient 0. I read 4 stories, dismissed the view controller 4 times. That should read persistent 0, transient 4. It does not. The memory has been allocated and does not go away. Now, the code for this. From the root view controller, it says, I'm your delegate, please present yourself. And the detail view controller says, great, I'll store that away. I'm sorry, what are you saying? Some people in the room think there's a problem with that. And they're thinking, it's going to be a weak delegate, everyone knows that, weak delegate, weak delegate. So they'd say, weak var delegate. Good, well done. Let's run it through instruments, shall we? Give yourselves a big pat on the back. Again, press record, go into the app, use the app like a madman, scroll around, tap on a story, dismiss the story, tap on a story, dismiss the story. Get a real feel for what it's like. When it's finished, you press stop in instruments, and you go down to the bottom left corner to the detail section, and you type the word detail in there, and lo and behold. Wait, what's that you say? Persistent 4, transient 0, Paul? So some folks will see this kind of problem and think, oh yeah, I've totally got this. The first view controller's got a stronghold in the second view controller. Second view controller's got a stronghold in the first view controller. I'll just break that and it'll be totally cool. But that isn't even fractionally what was the case. The first view controller has no say over the second view controller. It called present, Doesn't own it. You know, a UI kit takes care of it after that. This is not a weak problem. You're just sort of stabbing around in the dark. This is a problem with implicit retains because of one truly dopey feature in the app. When you find a story you like, tap on it, and it scrolls so you can read the story. It's lovely. Great feature, I'm sure. And this is done using some dopey code, which you may have used in your own apps. Timer, schedule timer, interval 1, target self, select a scroll, info nil, repeats true. This is what the Apple docs say. The timer maintains a strong reference to its target until the timer is invalidated. So the view controller owns a timer owns a view controller, they cannot free each other, Arc cannot do its job. This is so bad it requires a two-handed facepalm. Again though, easy fix. Just invalidate your timers. It's really easy to do. Most folks don't do it for some reason. And then you're back to being good again. So, before you get too pleased with yourselves, let's take it up a notch. Let's go up. We're going to go up to Time Profiler. This watches what code you run in your app and how long it runs for. That's its job. And we can run our thing through this. Again, here's a Time Profiler instrument. They all look more or less the same. You go ahead and press record. It'll have a good think about it. There we go. And you'll see it's having all the methods on the side here, all the threads being showed. And if I zoom in a bit on the threads, you will see there's what, 1, 2, 4 doing things, 3, 4. And they're all doing bits of work, you know, here and there, 40%, 20%, and so forth. They're having a go at doing some work. But the best bit of this one is on the right, the heaviest stack trace. This tells you which part of the code that was watched is taking up the most time. So if you're going to target one thing, that's where you target. And for me, it's right here, creating the images. I call UI image named. The black code is your code. The gray code is system code. I call image named, and it runs off and loads the image, and da-da-da. That's the slowest part for me, loading those images. And the code for that looks like this. 4 headlines, generate thumbnail. Now, to give you an idea of how long this takes, more graphically, you can just add a start time, add an end time, and then figure it out. For me, it's 2.359 seconds. That's what it takes to generate all those thumbnails, 50 of them, with the image on top. Now, this is clearly an embarrassing parallelizable problem. We can go ahead and make this work across multiple threads, and because you've got, iPad Pro is a hexa-core device, got 3 high-performance CPUs, 3 low-performance CPUs. We should be able to use the 3 high-performance CPUs at the same time and get some real speed-ups. So we can rewrite the code using operation queue and do the same thing, 4 headlines, queue add operation, the same code, end the block, end the loop, and then call wait until all operations are finished. Brilliant. 6.385 seconds. 3 times slower, which is going to stump you. It's like one of the cores was sleeping or something. What's it doing, To figure this one out, we're going up to the max. We're going to use my personal favorite instrument. I know it's weird, my personal favorite instrument. I've got one. It's System Trace. It's absolutely brilliant. It tells you what all your threads are doing and how the system's responding to that. It's an amazing, amazing tool. It gathers so much data, though, that it uses a thing called windowed mode by default. It records only a snapshot of time. As you keep on using it, it erases the last stuff, basically, otherwise it's just too much data. So by default, it uses windowed mode. So what you want to do is press record, get to your thing, do it immediately, then stop recording straight away. Don't let it carry on running, because it will just toss away the bit you actually cared about. And when it finishes rendering your loading your stuff, it'll go ahead, hopefully thinking about it. You can do it. There we go. It'll analyze, figure out what it looks like, and show you the results. Big mess of stuff, which is cool. Now, the easiest way into this, to begin with, is in this tab at the top, the CPUs tab. That tells you what each one of your cores were doing, physical cores were doing. And when I press on that, you'll see core 0, core 1, core 2, the 3 high-performance cores. And they look really busy. They're all working super hard to make those images load fast. But what you want to do is find some time in there, doesn't matter what it is, and then zoom in by pinching your trackpad or Command and Plus to have a closer look. And here's what you see. They're actually juggling the same work between them. It'll go core 0, core 1, core 2, core 1, core 2 again, back to 1, back to 0, 3, 2. And occasionally they'll just go nuts and juggle it really, really quickly, like here. But it's the same work. Now, to get an idea of what's causing this, also inside this profile tool, you can select a thread, any thread. And I want you to look again at the bottom right corner. Again, black code's my code, gray code system code. So the last of my code is UI image to create the image. And it shoots off into the image named function internally and starts doing all this stacks of work required to load images, which is actually, as you can see, quite a lot. Then it hits, at the end, a CUI mutable structured theme store. And after that, sort of the death part, Obj-C sync enter. It's a synchronized piece of code. It will lock a resource. And it ends up with the mutex wait, and just waiting and waiting and waiting. This obviously sucks. The bit you care about is this bit here, the CUI mutable structured theme store. In particular, the word mutable. So alarm bells. Now, inside of UIKit and SpriteKit and MacKit and kit, there are lots and lots and lots of these classes to work with. You may have used NSArray or attributed strings or character sets, datas, and dictionaries and so forth. These are all thread safe. I don't like wanting to memorize this list because the rule is actually pretty simple. These are not thread safe, right? The rule there is pretty clear, the mutable part. There's no sensible way, realistically, of having 2 or 3 or 4 threads all reading and writing from the same mutable part of data at the same time. And you should know, I hope, that UI image named, this thing here, uses a cache. When you load the image, it says it's in the cache. No, fetch the image, put it in the cache. And that way, next time you ask for it, it's there. But I don't need these thumbnails in the cache. I load them and render them to other images to display on the screen. Cache is irrelevant to me. I don't need this. This is being lazy. And that's causing the lock. That mutable store for the image is causing the lock. Fix. Find the path yourself and use contents of file instead, which does not use a cache, therefore it does not require locking. The early code was 2.359 seconds. The naive multi-threading was 6.385 seconds. The new version is 0.471 seconds, significantly faster. So, let's see. We've done why instrument, we've done what to instrument, we've done when to instrument, we've done how to instrument. So I'm going to try and summarize for you. Firstly, stop your mediocre drawing before it kills again. Learn to draw efficiently, and your users will thank you for it. That means you need to check your core animation frame rates on real devices. It means you make your views opaque. It means you draw them at a natural size. It means you skip a second draw pass if possible. And you've tried prefetching cells if it helps you. Because in the time it's taken me to talk this much, the iPad Pro has done 250,000 draws, right? It's extremely fast. You cannot hang around with your drawing. And check for leaks. Because if you are not currently checking for leaks, that is not what you have. That is what you have. So check. Look for abandoned memory. Stuff you put to one side, used it for a while, and don't need it anymore. Well, get rid of it. Cached memory. Image named is a cache. There are other ones like it. Do you need your own cache? If not, don't use it. And if you do need a cache, don't use NS Dictionary or NS Mutable Dictionary or Swift dictionaries. Use NS Cache. That's what it's there for. And of course, leaked memory. If you're losing stuff, get it back, like our view controller. Don't just sort of spray weak everywhere and hope for the best. It's not good enough because of implicit retains. Instruments is a contact sport. You've got to get up close and personal with it. You can't stay at a distance and hope for the best. You've got to learn what the numbers mean. Even if you only remember the ones I've showed you today, these will take you a long way in making better apps. Now, in my test program, all the threads were fighting for the same resource. We used 2 different instruments to find what was going on. And that's cool, because you'll find that Tim Toady, there's more than one way to do it. Tim Toady applies an instrument. There's so many instruments, and they kind of overlap in places, and that's cool. Use everyone you like, whichever one's easiest for you. Just use that. It's fine. Your target number 1 should always be the time profiler's heaviest stack trace. It's telling you you're spending most of your time there. And you can do, if you want to, amazing micro-optimizations using functional, very clever. This bit, the image loading, is a slow bit. Fix that, and it'll make itself irrelevant, basically. But the time profiler only measures code that's actually running right now. And that's why it didn't spot the problem with the multi-threading, because the threads were blocked most of the time. In fact, nearly all the time they were blocked. So check your thread states. Are they fighting? Are they preempting each other all the time? And, as you saw me do repeatedly here, test all changes. Make a small change, try it again. Make a small change, try it again. What you don't want to do is make 10 changes, then find out it's slower for some reason you're not quite sure why. Because 9 of them could have been brilliant and 1 could have been a disaster. Small change, test. So please test all changes. You saw in my example, the leak was not the result of a strong delegate. That was perfectly fine to use that. My performance got slower with the first multi-threading implementation. Do not try to trust your gut. Instruments will tell you exactly what's going on. Now, if you spent the last 32 minutes listening to some Game of Thrones British guy speaking about instruments, fine, zone out if you want to, that's cool, but at least remember these following tips. Firstly, always profile on a real device. That was my iPad Pro being filmed the entire time. It's the only way to know for sure. Used to be in the old days, you had to do it on a real device because your Mac was so much faster than the iPad. Nowadays, your iMac is so much faster than the Mac, so you've got to do it anyway. Test in a real device. And always profile on the oldest device you support. So, for a long time, it was like the iPad 3, right? That was a disaster device to work on, but it was used by some users. So find the slowest, mankiest phone or iPad you can get your hands on and test on that. And again, make a small change. Profile again. Small change, profile again. As a reminder, you can send your instruments hate mail to @2straws on Twitter. Please do vote in the Swift Community Awards. There is a category for best conference. I'm sure the Pragma guys at the back would love you to vote for them. Anyway, thank you very much.